Looking at normal distribution using Excel, let's see what our question is again here. We have the average speed of vehicles traveling on a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. A vehicle is selected at random. What is the probability that it is violating the speed limit of 70 miles per hour? Assume the speeds are normally distributed and are represented by the variable x. So basically, what we can do here is kind of pick up on this normal distribution part is I can draw the normal distribution curve. So have to bear with me here. It's probably better to just have one. So we have a point of inflection. So we'll go like, well, usually we have three standard deviations here. 1, 2, 3, 1, 2, 3. So the average speed is 67 miles per hour. That's our mean. It's going to be out in the middle. And then if we go 3.5 each way, so 67 and 3.5 would be 70.5. And then if we add 70.5 and another 3.5, that's going to be 74. And then if we add another 3.5, that's going to be 77.5. So if we lose 3.5, that's going to be what? Lose 3 would be 66, so 65.5. Lose 3 would be 62. Lose another 0.5 would be 62. So 62 plus 3.5 would be 65. And then if we lose another 3, it's going to be what? 59. So 58.5. So if I did my math right there, 3.5 would get us back up to 62. So our normal distribution curve would look something like this. So our question is, what's the probability that they're violating the speed limit of 70 miles per hour? So what they're talking to talk about is 70 is here. So 70 is about here. So what they're asking for is what's the probability of being greater than 70 miles an hour? So they're looking for this. Now, in using the Excel, what I can do is I could find the probability, which is going to be cumulative from left to right. So if you're using Excel, normal distribution is going to be, if you hit the equal sign, you can start typing in normal, N-O-R-M. Well, gotta get a N-O. Notice how normal distribution shows up. If I click on it, so notice how it wants three fields, X. So our X is going to be where we are. The data point is 70, I should say. And then our mean was the 67. And our standard deviation was 3.5. And cumulative means we want to add from over here to over here. So the cumulative is going to be this step over this way. So cumulative is going to be from way over here to way over here. So remember, when it does cumulative, it goes from left to right. Now, to make it, if we get back to the formula here, so the cumulative part, there's a true or false part here. If we say true, then we want cumulative. If false, what that means is it will do exactly just the 70 miles per hour. So if I put true there, we want cumulative. If I hit enter, it'll give me the probability that this is going to be over here would be this 0.8043. That's going to be the probability of going under 70 miles per hour. So what I really need is 1 minus the 0.8034. So notice how this is going to be the less than, but if I go here in another box equals, I can go 1 minus, and then A3 is where that's at, A3. It should give me the other side of that, which would be 0.91, 0.1957. So 0.1957 would be that probability. So that's how I could do this on Excel. Now, if I want to verify that using the calculator, let me pause for a second here and see what we come up with. So if I want to do the same problem using the graphing calculator, I could go second distribution. Number two is the normal. Let me get this out of the way. Notice how the lower bound is actually going to be, because we want greater than 70, so 70 is going to be the lower bound. There's not going to be an upper bound. That's going to be the 10,000. Our mean was the 67, and our standard deviation was the 3.5. So our calculator also has the ability to do the normal distribution, and it kicks out then the 0.1957. So it would give us the same answer. So we can use Excel, or you can use the graphing calculator.